we need to know this information for the question. Okay, there's the general quadratic ax plus bx plus c. Now then, depending on the discriminant, which is the part in the square root of the formula, which is b squared minus 4ac, and then if that is positive, i.e. if it's greater than naught, the roots are real and different, and we call that real and distinct. If b squared minus 4ac equals naught, it means I have the same root twice, so I write that as roots are real and equal. And if b squared minus 4ac is less than naught, if it's negative, I can't find the square root, so there are no real roots. Now the only other condition we have to sometimes deal with is if I'm told the roots are real, then two of those categories fit that, the roots being real, greater than naught or equal to naught, then the condition for real roots is b squared minus 4ac greater or equal to naught. So that's the information I'm going to need to work out the next question. So part A, part 1. Assuming that the quadratic equation has two equal roots, show that. Right, so the first thing we must do is the condition. For two equal roots, so that means real and equal, and the condition for that is b squared minus 4ac equals naught. I must have that condition before I start. Then identify a, b and c from the quadratic. So a is the coefficient of x squared, so that's k plus 1. b is the coefficient of x, which is 4k plus 1. And c is what's left over, which is k minus 5. So I substitute these values of a, b and c into this discriminant formula. So I've got b squared plus 4k plus 1 all squared minus 4 times a, which is k plus 1, times c, which is k minus 5, and from the condition, if they're equal roots, that has to equal naught. So to square this bracket, then three terms to square in the bracket. Square the first, square 4k is 16k squared. Multiply them together and double it, so that's plus 8k. And square the last term, square 1 is 1. Minus 4, and here I got two brackets next to each other, so I need to do FOIL on that. K times k, k squared, minus 5 times k, plus 1 times k, 1 times minus 5 minus 5 equals naught. And then I've got a 4 outside the bracket, so I need to multiply these terms inside by 4. It's minus 4k squared. Minus 4 times minus 5 is plus 20k. Minus 4 times k is minus 4k. And minus 4 times minus 5 is plus 20. Equals naught. So collect the k squared. 16k squared take away 4k squared is 12k squared. 8k and 20 is 28k. Take away 4k is 24k. Then I got 1 and 20 plus 21 equals naught. Then if you look at the three terms, they're all multiples of 3. So if I divide that equation by 3, I've got 4k squared, 4 3s are 12, plus 8k plus 7 is equal to naught, which is what they asked me to show in part 1. Part 2, hence show there are no real values of k such that the quadratic equations has two equal roots. Right. So it's not we're not imposing a condition on this quadratic directly, okay? Because we want this quadratic to have two equal roots, then I need to be solving this quadratic. But they say and show there's no real values of k for this quadratic here. Okay, so no real values, so no real roots if b squared minus 4ac is less than naught, and that's for this quadratic. Okay, so I don't want any answers out for this quadratic to show that the first quadratic doesn't have two equal roots. So identifying A, B and C from this one then. A is 4, B is 8 and C is 7. So let's calculate b squared minus 4ac. So b squared minus 4ac, that's 8 squared minus 4 times 7. So that's 64 minus, right, 4 fours are 16 times 7. So 64 take away, right, 16, 7, 7, 16, 7 times is 70, 7, 6 is 42, 612, and 64 take away 112, that's a negative answer. So let's just take them away. That's 12 divided by 8, 48, so that's equal to minus 48, which is negative, so there's no real values. Okay, which is less than naught, therefore no real values. Okay. Right, part B, find the range of values satisfying. So we're solving this inequality, straightforward inequality. So the first job is to factorize this quadratic. So we get the key values. So to factorize this, I can go 4x all over 4, multiply the 4 by the 9, that's 36, and then I'm looking for two numbers to multiply to give 36 and take away to make minus 9. So 3 12s are 36, difference of 9, so the two values are 12 and 3, and I want to make minus 9, so it's minus 12 plus 3. So 4 is a factor on the first bracket, it's x minus 3, 4x plus 3 4, so the 4's cancel out. So the inequality will now factorize to x minus 3, 4x plus 3 greater or equal to 0. So I've got my key values. Key values then will be x is 3 and x is minus 3/4. Okay, there's the key values. So I need a sketch here to see for the range of values of x. It's a quadratic, positive quadratic, so it's a U shape. Let's cut in at minus 3/4 and cut in at 3. So I want to know where this curve is greater or equal to 0. This line here is where it's equal to 0. So greater or equal to 0 is above the axis. So it's above the axis, and then this side of 3 and this side of minus 3/4. So the solution is going to be then from minus infinity up to minus 3/4, joined with from 3 all the way up to infinity. Now infinities always have a round bracket, and to decide whether I get a round or square bracket, I go back to the inequality. Because this is greater or equal to, then it can take the key values, so that has a square bracket on the key values.